Hello and welcome to What is DevOps? So in this video, we're going to talk through not just the book definition of DevOps, but I'm going to give you some examples of how DevOps is applied in an organization and really what it tries to solve. So by that, you'll end up getting the definition of DevOps, but we'll go a little bit further in depth than just a basic definition. So first, let's talk about what most software development lifecycle organizations look like internally. All of them do this a little bit differently, but the main premise exists across the board. There's some type of idea for a new feature or a new product. And so that idea then goes to some sort of business analysis, feasibility, return on investment, understanding, right? Whether that's part of a team or part of product management or where that resides, but that's the analysis it goes through. And then eventually, once they decide to do the thing, the feature, the product or whatever, it's given to application developers. Whether they're doing Agile or not almost doesn't matter in this instance. So this applies to organizations that are still doing things in a waterfall method as well. And then some level of quality assurance and testing is done at some point. Now that could be, again, part of an Agile team, or it could be a separate group. And then the release management side, now this could be part of IT operations or a separate team or something like that. But QA is going to give that code and say, yeah, this can be released and deployed. And then IT operations is responsible for managing the infrastructure and the coding, where the coding is housed. And really delivery of that feature or that piece of software isn't done until the end of that pipeline, right? So the problem with this type of concept is that there are handoffs, just like a game of telephone. There's pieces of information that are not passed. There's maybe extra pieces of information that are passed that cause problems down the line. And those problems manifest themselves when it comes to deployments, right? And this is one of my favorite views of deployment. You show this to somebody that has done a software deployment in the past, and they immediately go, "Oh, I identify with that," because deployments don't really work all the time. And I'm going to give you one small example of why they may not work. And I'm going to call this Snowflake, but there's no reflection of age or political preference here. It's just the word snowflake, and basically showing that there's a lot of differences in your environment. And so, for example, I'm just going to do a basic example of I've got some new code. I'm going to deploy that to our environment, and I have 3 servers. So there's really not a lot to get boiled in the minutia of how many servers are being involved in your infrastructure. So in this case, there's 2 servers that are Windows Server 2016 standard and one that is Data Center Edition. So slight differences. It's still a Windows server. It should still work the same, right? Well, when you look at their Windows Update versions, you see those are different, which means they're patched at a different level, which then, there is major differences in the way that they would operate, or at least very minor differences that may get lost in troubleshooting, or why does something work for one customer and not for another. And this is really the reasoning is, if you don't have standardization across your infrastructure, there could be differences. There could be things that cause an issue for one user and not another, or for at one time and not another. And it's easy to see here in an instance where you're talking about 3 servers, but what if you have an instance or an environment where you have tons of servers, hundreds or thousands of servers that are providing your production environment? And what about the differences in all of those servers? So this concept is a thing called configuration management. It's actually a tenet of DevOps, and one of the things that DevOps solves for. So this is an example of a small thing that DevOps tries to manage and maintain. So what do I hear from clients when they have these types of problems that DevOps would be able to solve for? So the first is we need to get software releases out faster. Maybe they're only doing 1 or 2 a year, and they're trying to figure out how to get updates out more quickly, more frequent to the market. All deployments cause multiple issues. Again, back to the deployment thing. Every time we do a deployment, there's a problem. Our production environment isn't the same all the time. It kind of goes back to that configuration management principle. And then IT operations is having a hard time keeping up with Agile teams. Agile teams want to quickly produce value and have that value be seen, getting to the end of that pipeline, if you will, as quickly as possible. And IT operations sometimes doesn't want to change, and we'll talk about why that is. So let's talk about the main constituents in DevOps, and it's pretty simple. It comes from the word, right? Dev and ops. It's the development teams and IT operations teams. And let's talk about their motivations for a bit. So on the development side, as I mentioned, they're in most cases, following some type of Agile methodology, and because of that, there's a lot of value seen in how frequently you deploy or how frequently you can show your customer the value of the thing that you've worked on. Hey, here's the blood, sweat, and tears that I've put into this project for the last couple of weeks. I want you to see it, right? I want to show off my changes, the things that I've done to enhance the value of the organization. And then conversely to that, you have IT operations who they don't want to change anything. They're penalized for downtime. They're rewarded or potentially bonused for uptime. They don't want to change anything because from change comes problems, and that they have to fix. And sometimes that's 3 in the morning or at another time when they don't want to be doing that type of work, right? So this creates this battle between IT operations and the development teams of, I want to change this. No, you're not allowed. And because of this, you end up having what I like to call pseudo DevOps, and that pseudo DevOps is really not DevOps. And because of that, people don't like the term DevOps because it doesn't really provide the value, right? They're just saying DevOps and not really doing all the practices and all the things that really mean a DevOps implementation. So what are organizations trying to achieve with DevOps practices? And I think this is a very complex answer. So the definition that I'm using in this video is one that the DevOps community, I think, would agree with. It's not the Webster's definition of DevOps, but I think it highlights the most important parts, and we'll talk about why those parts are important. So it's smaller batches of software work. So smaller batches go through the system quicker. This is a phrase that lots of methodologists and folks in the DevOps community talk about. So smaller batches going through that system, deployed more frequently. So we don't want to do 1 or 2 deployments a year. We want to do 1 or 2 deployments a day. Very small changes, deploying that to production. And then with less planning and more adaptability, that basically says without a lot of heavy stuff, and we'll talk about lean and waste and whatnot. And then the last part is by people working better together. There is a human component here, and we'll talk more about that in a second. So that's the definition, the kind of the book definition of DevOps, and something we can build on from there. So the early adopters of DevOps and the early part of the DevOps community, Damon Edwards and John Willis, they came up with this acronym called CAMS: Culture, Automation, Measurement, and Sharing. The culture part is basically, I need to get IT operations and the development teams to see the world the same, to realize that we need to create a positive culture that is ultimately benefiting the customer or the marketplace or the company as a whole. And if both of those constituents can see the good and doing an action, then they should be able to work together better. And so there's this concept of culture. And I hate that culture is first in this acronym, but I think it's also showing how important it is. And for folks in the technical realm to have to realize that culture is more important, or that one of the most important factors, it's kind of a puzzler for folks that are really trying to adopt DevOps, which I think is a good thing because it makes them think. The second part is automation, and that's automate everything. You want to remove the possibility of a human mistake from almost everything, whether that's on the dev side or on the IT ops side. So automate, automate, automate. This is where tooling comes in, and we'll talk a lot about tooling in this video as well. Measurement, the phrase with measurement here is, if you want to get better at something, you have to be able to measure it. And this this concept means tons and tons of logs, tons and tons of graphical displays for that data, so that if there is a problem, whether it's automated or not, you can go back and find out what was the state of the world, what were the state of our systems at that time. This measurement allows you to then say, oh, this is a problem, we need to get this down to that number, or we need to increase this to that number. And as a team, you can see that number and you can aim for that number. So that measurement allows a culture to kind of exist, really. So the automation, measurement, and sharing really contribute to how the culture is organized. And then the last part of this acronym, the sharing portion. And I think the base concept here, shared vision, shared understanding, shared responsibility. And if everybody shares in that, then that kind of fosters the proper culture, if you will. So that was the original founding concepts of how to deploy or how to provide a DevOps practice in your organization. And there was a lot of folks that have followed this acronym. And over the years, Jez Humble came through, and Jez is the author of many books in the CI/CD and DevOps space. But he added the lean portion to this, and basically to help engineers both on the development and IT operations side understand that this doesn't have to be this really hard, convoluted, large process thing. DevOps can be very scaled down and lean, and applying that to a DevOps practice is really important at the end of the day. So that's comms, and the lean portion was a really important addition to that. And then you have the scaled agile view of DevOps. And rather than the S for sharing, they changed that to R for recovery. And I like that from the standpoint of to get the culture, you have to be able to work well together, right? And not that sharing is a bad thing. Sharing is to me one of the most important parts of it. But I think that really could be encapsulated in the culture aspect of this acronym. But what the CALMS acronym did not talk about was, if we're deploying something and we're deploying very frequently, how do we get back to a better state if we deploy a problem? We deploy something and we go, uh-oh, that's not good. How do we roll back? And I think having that recovery feature inside of this concept is really important, because you have to be able to have that as a founding part of a DevOps implementation. So the culture thing we talked about, if you could just do the culture thing, that'd be great. It's very hard to do. And I almost think that it shouldn't be the first thing, because people start to focus on that alone. But really, there is a book, there's a guide for how to implement a lot of these things. And it's the State of DevOps report. It's come out for many, many years. The things that came out in 2014 are still true today. And it talks about things like version control for all the things in production. And if you don't have that today, that's a practice you should probably implement. Each one of these very high performing IT companies have a continuous integration and continuous deployment process, which is very defined. They have automated acceptance testing. They have peer reviews of their production changes, which I think ultimately will create a high trust culture. They have proactive monitoring and measurement in the production environment, and that ultimately creates a win-win environment with dev and ops, right? So this not that it's a playbook per se, but you can start to identify things in your organization that you don't have just by looking at the State of DevOps report. You'll find out what you don't have. And a little success story I like to talk about in the DevOps world is Werner Vogel's at Amazon, and he said this in the early 2000s. I think it was 2004, 2005. You build it, you run it. And the concept here was each team inside of Amazon would build an API for another team to use. So imagine there was a team that built the login feature, and a team that built another feature and another feature, and another team may need to call the login feature. So they would just use their API and call what they needed to. But the problem is if they had, they would just put some documentation up and not really service it. His point was, if you're going to build something for another team to use, you have to be able to be the customer service support desk for all the things that they built, right? So that allowed people to have to talk, or it forced people to have to talk and communicate and say, oh, we built this thing and that's not useful, not as useful for you, but if we tweak it, maybe that would be better. Okay, cool. I understand what you're doing and I can help you now. And now I'm going to go back and enhance something and make it even better. And that culture of kind of shared responsibility and being able to communicate with one another actually made the output better for what they do. And so if you look at some of the stats that are out there for Amazon, 11.6 seconds between deployments during the week, 10,000 hosts receiving a deployment at the same time, over 1,000 deployments in a single hour, and over 30,000 hosts receiving a deployment. And this is not now, this is in May of 2011. So yes, Amazon is a newer generation business, and they're not dragging a lot of legacy technology forward. But I think if a company like this can use those concepts to get these numbers, companies that do have legacy technology should be able to, over the course of 5 or 10 years, be able to convert a lot of that technology into newer stuff that can be DevOpsy, that can have these types of stats. So I've talked about some of the continuous words a little bit in this video, and I want to get into some definitions of that, because I think to understand the concept of DevOps and its definition, you have to understand these continuous words, what they mean and what their ultimate goal is. So continuous integration, you'll hear this referred to as CI. It's doing a build and a test every time that you change the system. That could be every day. That's a good practice. And it also is this concept of making sure that you're working off of a shared trunk and not feature branches. Feature branches in general nowadays are a bad practice. And if you disagree with that statement, go read a book that I'm going to talk to you about here, about a transformation with HP, and how some small changes in their understanding of continuous integration actually revitalize their business. So we'll talk about that here in a bit. But continuous integration, again, builds and tests are done all the time, very frequently, continuously, essentially, so that you don't have these big windows of, oh, everybody has to integrate their code. The next continuous word we'll talk about is continuous deployment. And this is after a CI build passes, getting it automatically to production or potentially some other validation or performance testing environment. But basically, this thing is good to deploy, right? This thing is in a production environment after it's been automatically tested and the build successfully passes. So not every business can do this, which is why you have the next continuous word, which is continuous delivery. And this is when you hear people reference CI/CD, they're really talking about this concept of continuous delivery. And this is really trying to be able to get to a continuous deployment state, but it may not actually hit production. And so this is a great example of this is there's updated firmware for a printer or a server or a laptop or a desktop. It's in an available state. It's maybe on a support website where people can download it, but it's not actually deployed to the equipment itself. Same with mobile apps. The app is updated in the App Store, but your phone hasn't actually downloaded it and updated it quite yet, because Apple or Google do not allow you to do that 20 times a day. It's only done, once or twice a week or something like that. So continuous delivery is the state that most businesses would like to get to. Continuous deployment is a great state of Zen where, the CI build passes and it gets directly to production, but continuous delivery is the state that a lot of businesses will want to focus on. How do we get it to a state that can be delivered? And to illustrate this, I've actually I've got a graphic here that walks through what this looks like. And I've used days, but this could be hours, any unit of time that is generally small. But I'll use days for an example, assuming that the CI build only happens once a day. Let's say you have a large system and that happens at night because it's got to run security tests or something like that. And that takes time. So the first day is this first section here. A developer will check in the code and version control that will trigger a build, and at night that developer will then get an email saying that it successfully built. And let's say it didn't, it's red here. So that that developer on the beginning of day 2 comes into their inbox, they see an email, hey, my build didn't pass, there was an error. And that second day, the developer can then go, oh, I made this mistake, I forgot a semicolon, let me update that and push it back in and let it build again. Oh, it builds successfully, it goes the automated acceptance test and it fails. It emails that developer that night. Beginning of day 3, the developer comes in, they see they have an error that it didn't meet the acceptance test, and they go, oh, it's something I can fix real quick. It's right in front of me. I was working on that yesterday. Day 3, they make that change, they check it in, it passes the build and the unit test, it gets through the automated acceptance test, it passes the user acceptance test, and it's ready to be released. Somebody clicks a button, says, yes, this can be released to production, right? So this is an example of a deployment pipeline and what that looks like through the build and test criteria. Now, the reason continuous integration is really important is because this is over a short period of time. Now, imagine this could be, hours as well, right? Hour 1, hour 2, hour 3. How quickly that feedback comes is based upon how the build is done. Does it take 30 seconds, or does it take an hour and a half, or 5 hours, or whatever, right? So there's a unit of measure, let's say, is a day or less. But think about how quickly a developer can realize, oh, I did this yesterday and I can fix that code today, as opposed to a mistake is made in a waterfall environment. A mistake is made and you got 6 months before integration happens. That developer may be on a different project, it may not be with that company anymore, and then the integration fails and somebody has to figure out, why did it fail? And this delay is really adding to the delay of fixing and getting something to be deployable, not having a continuously integrated system like this. So short intervals, no more than a day, something like that you can see that feedback and get that change and get it back in the system. Excuse me. Tooling is important here, really, really important. But keep in mind, the CALMR or CALMS acronym, culture is the first thing, and even in the CAMS acronym, sharing is on there too. So don't get focused only around the tools. The tools should help create that proper culture and that environment that allows the work to get done right. So I'm going to go into tools now, but keep in mind that it's not the most important thing. It's just an enabler to allow the organization to work together better. So if you've ever seen this is the DevOps periodic table of tools. There's tons and tons of tools on here. I was showing this to somebody the other day and they went, wow, I didn't realize there was this many tools. And there's really even more than that. This is just kind of a first pass from many years ago. If you're not a DevOps person, you're not an IT engineer, you're not or IT operations engineer, you're not a software developer, or even if you are, you don't have to understand all these tools. I say focus on just the top legend there. That legend is really important to understand the types of tools that are in existence in this chart. And I think that's really where the power comes from, to understand tools better. And understand why you would want one tool over another, or why these tools exist. So I want to run over just some quick notes on those categories so that you understand those better, and why they're important. So source code management, SCM. This is stuff like Git, GitHub, Bitbucket. These are tools that will version your code and will also allow multiple people to work on the same source code at the same time, which is great. And then it'll also help merge those, which is continuous integration. So that's stuff like Jenkins or Bamboo or Visual Studio that merges the code together. All those changes from different people, and it does some basic tests, right? It's getting it all back together, and can it build? Deployment. So this is something like SmartFrog, which actually puts the code, the past build that you created in your CI, and puts it into production. Cloud, infrastructure as a service, platform as a service. So this is your Azure, AWS, Google Cloud Platform, things that you're used to from an infrastructure perspective. BI and monitoring. So this is stuff like Nagios, Zabbix, New Relic. This gets to that measurement portion that we talked about in the CALMS acronym, being able to monitor and measure those types of things. Database management, like Liquidbase. This is, how do you manage your data infrastructure, automate from an automated perspective, right? This is my DBA doesn't have to be in the database every day, all day. Repo management. So this is stuff like Artifactory, which will allow you to kind of encapsulate all of the things that are artifacts in your environment, that you want to make sure that is kind of a little bit of saran wrap is put around so that you know what all goes together. And then configuration management, which is stuff like Chef, Puppet, Ansible. And these are from the beginning example that I gave about you have different versions of Windows Update. Stuff like this will help you identify those types of problems, the needle in the haystack, so to speak, so you can go and fix those things and get them all standardized so that they're the same across the board. And you can actually use those applications for provisioning of new services as well, because it'll understand what your base image is, so to speak. Okay, so next is things like release management, like Urban Code. This is how you deploy something, how you're going to organize it, and how you're going to structure it. Logging, which are tools like Splunk and Sumo Logic, which take a lot of these logs and analyze that and give you smarter dashboards to look at, as opposed to trying to understand what's going on in 50,000 different pieces of equipment and virtual environments. Build, which is stuff like Maven and Broccoli and even Make. This is just compiling the code that's been provided to it. Testing for automated testing is stuff like Selenium and Cucumber, which allows, because it's automated tests, it allows it to get through the testing phase more quickly, as opposed to waiting on a manual tester to test and do all your test cases. Containerization, stuff like Docker and Kubernetes. This is allowing multiple versions of a certain type of software to sit on an operating system. Just kind of containerizes each one of those, and so you can call and use just the ones that you need, which is very, very beneficial for some legacy older technology, and allowing it to have multiple versions on the same physical or virtual equipment. Collaboration, this is stuff like Jira, Slack, ServiceNow, ways that you can organize your workflow and multiple people, and you can all march to the beat of the same drum. And then lastly is security. So tools like Snort that are going to organize your environment and make sure that there's no outside attacks, and if there are attacks, what are the procedures and policies that it's going to go through. So this kind of gives you an idea of the categories and the tools that are in those categories and why those are important. And they're the main constituents inside of DevOps from a tooling perspective. All right, so let's wrap up. I did mention a book earlier, and we'll talk about that. That's actually the middle one, that's Leading the Transformation. So if you disagree with me in my point of feature branches are bad, please read that book. Another great book, The Phoenix Project, that's a fiction book, and walks through a lot of scenarios that folks in IT operations and engineering probably go through. And it really talks about how DevOps was implemented almost from the ground up to create solve a lot of problems. The book on the right was written by Jez Humble and David Farley on continuous delivery in 2011. And if that date is important, think about the Agile Manifesto that was written in the very early 2000s, and it talked about the continuous delivery of software. And there wasn't a book written until this book was written in 2011. So pretty interesting book. It does read like VCR instructions, so beware, but it's a really good book, and it talks about the infrastructure and the methodology by which you can employ a continuous delivery environment. Another, as I've mentioned this before, another really important read is the State of DevOps report. As of this video, the 2021 2021 State of DevOps report is out. Definitely go read that, and read that every year. It has some really good information, and very, very valuable if you're planning your DevOps journey. And that's all we have for this video. So thank you for watching, and hope you learned something. Thank you, and have a great day.